like freeze 내 몸이 굳다가 Hey dear, stay here 내 눈이 멎다가 No way, losing my way No way, 멀어지기만 해 아프기 싫다 난 깊어만 감하면 어떡하냐 난 아무 말도 들리지가 않는데 난 아무것도 보이지가 않는데 네가 나를 떠난 그날부터 무엇 하나 할 수 없는 나인데 모두 멈췄어 모두 끝났어 내 모든 게 지워져가 눈을 감아도
Alright, so now we're going to talk about logarithmic equations. A couple of examples of where logarithmic equations are used would be to measure sound intensity or to measure earthquake intensity, like on a Richter scale. So in order to help us solve logarithmic equations, it's a good idea to kind of keep this goal in mind. One goal would be try to write a logarithmic equation so that you have the log of something is equal to a number. Y is just any number. Okay. The reason why is because then you can rewrite this as a to the y is equal to x, and then go about your merry way. Okay, so that'd be the first goal you'd try to write things in. The second one would be, can we write this as the one logarithm equals another logarithm, provided you have the same base, of course. Why? Because this means that the two arguments have to be the same. Right? So that's kind of the goal. When it's logarithmic equations, you're trying to write it as one logarithm equals one number, so then you can use the definition of a logarithm to rewrite it in exponential notation. Or you're trying to write one logarithm equals one logarithm, provided you have the same base, and then you can say, alright, well then this argument has to equal this argument. That gets you over here, and then you can go solve your equation. Okay? Alright, here we go. Okay, so log base 4 of x minus 1 is equal to 3. This is a logarithmic equation because what you're trying to solve for, x, is located in the argument of a logarithm. Now we notice that we've got one logarithm here equal to one number. That's nice, because now we can just rewrite this using the definition of a logarithm as 4 to the third is equal to x minus 1. Everybody see that? And then you just solve for x, right? So that'd be 65 is equal to x. Right? Now there's one other thing about logarithmic equations that we have to be careful about, and that is this 65 down here is definitely a solution to this equation in blue right above it. No question about it. But it may or may not be a solution to your original logarithmic equation. And that's because you've got this argument to worry about. Remember, the argument cannot be 0 and it cannot be a negative number. So we need to just check that. If you take the 65 and plug it in for the x, what do you get inside the argument? Well, you get a positive 64. That's fine. Nothing wrong with that. Right? So therefore 65 would be a solution to this equation. But if you were to take your 65 and plug it in for x and get a negative number inside the argument, then you would not be able to use that 65. Okay? We'll see an example like that in a minute. All right, let's try another one. All right, so log of x minus 6 equals 2 minus the log of x plus 15. No, you cannot distribute this log through and write this as the log of x minus the log of 6. That's because this is not multiplication that's going on here. Right? This is all one notation. The log of x minus 6. It's all one thing. The most common error is to distribute the log through. Please fight that temptation. Alright, so we notice that we've got a log here and a log here. They're the same base. Alright, so it looks like we're going to need to do a little work. So let's get all the logs on one side. And so we would have the log of x minus 6 plus the log of x plus 15 is equal to 2. Alright, now what do you think we can do with that left-hand side? Alright, we can use a property of logarithms. Since you have the same base and you're adding, we can now write this as one logarithm, and the argument would be x minus 6 times x plus 15 equals 2. And now we've written this as one logarithm. We use those properties of logarithms to take two logarithms and write it as one. Right? And now we can do the definition of the logarithm and rewrite this as, what's the base down here? It's a common log, it's 10. So 10 squared is equal to x minus 6 times x plus 15. Right? And now we just solve this equation. So you get 100 equals x squared plus 9x minus 90. And now we say, what type of equation is this? Well, this is a quadratic equation, right? So everything on one side and 0 to the other side. So it'll look like such. Alright, so now does that factor? Right? Factors of 190 that subtract up to 9, yeah? So that would be x plus 19 and x minus 10. Now what do we do with each of those factors? Set each factor equal to 0 and solve, so you get x equals negative 19 and x equals 10. Everybody see that? Alright, but now we have to check to make sure that neither one of these numbers make any argument, negative or 0. And everybody see, if you take negative 19 and plug it in for x right here, you would get negative 25. So right there, that one situation where the argument becomes negative means we can't use negative 19. Right, so 10, if you take 10 and plug it in for x up here, you get a positive 4. That's cool. If you take 10 and plug it in for x right here, you get positive 25. That's cool. All right, so then 10 is the solution to this logarithmic equation. So we've got that one extra step of making sure that your possible solution down here does not make any of your arguments negative.